All right. Today we're going to talk about a difference of squares. This is a typical uh, shortcut. This is a type of factorization that you need to be able to recognize. You need to be able to, when you see this, what you need to be able to do is to factor these on site without having to worry with them. This is a very easy lesson, but you have to remember it. It's called a difference of squares. Now, what I mean by a perfect square is something where I can take two integers or a combination of integers and variables and square it. For example, 2 squared is 4. So 4 is a perfect square. If I have 3x and I square that, then that is 9x squared. And you probably really need to learn all your squares through about 20. 12 squared, we'll say 12y. If I squared that, would be 144y squared. And so those are perfect squares, something I can take the square root of and have not a fraction or any kind of decimal, have a nice answer. So you need to look, what you need to look to identify, these are perfect square binomials. Notice bi means there's only 2 terms in it. We've done trinomials, but we're going to make this a trinomial. If you think about it, we've got a squared plus 0 minus 1. And usually in our trinomials, we had form ax squared, and we had plus bx and plus c. And c was some constant. A was the coefficient in front of the variable, and b was another coefficient in front of the variable. Well, if there's no middle term there, that means that the coefficient in front of it must be 0. So we could rewrite this as a squared plus 0 times a minus 1. Okay? And so we have minus 1. And the value of that is still a squared minus 1 because 0 times a is 0. But then we go back and we think just like we did before with our trinomials. Okay, I need something that's going to add up to be 0 and multiply to be negative 1a squared. Okay, well, the only way we can get a 1, factor of 1, and again we have 1 of each because this is negative, is plus 1 and minus 1. And that will add to be 0a. So let's go through and factor this just with our box like we did. We put a squared here, minus 1 here, and to get this 0 we had to figure out what these were. We have 1a and minus 1a. So go through and find the area of the box. A times a will give me a squared. A times 1 is going to give me 1a. A times negative 1 is going to give me negative 1a. And 1 times negative 1 is negative 1. So when we read our factors of this, we have a plus 1 times a minus 1, and that equals a squared minus 1. And that would be the answer to the factorization of this difference of squares. And so you see, difference means subtract, right? So we have a binomial at each end. Each of these we can take a square root of, and there's a minus sign in the middle. It does not work for a sum of squares. A sum of squares has no real solution. We cannot do this if there's a plus there. So you have to remember that. All right, so we have, do this one. We can rewrite it again as 9b squared plus 0b minus 4. Well, I need it to add to be 0, and I need terms that is going to multiply to be 36, negative 36, b squared. Well, that would be 6 and negative 6, and we need the b on it. So let's fill in our squares. We have 9b squared minus 4, and we've determined that our factors must be 6b and negative 6b to give us the middle term, which is 0. All right, we can do 9 and 1 or 3 and 3. The way 6 is a multiple of 3, so we're going to say this is 3b times 3b. That gives me the 9b squared, plus 3b times 2 will give me the 6b. 3b times negative 2 gives me the negative 6b, and then 2 times negative 2 is negative 4. So we have 9b squared minus 4 is equal to 3b plus 2 and 3b minus 2. So the pattern, if you look at these, what pattern do you notice? And you need to put this in your own words. I'm not going to try to write this all out with my pen. We did it in class, and we will do it in class, and but you can write down what I'm saying. What you see is that the first term in each of the factors is the square root of the first term of your original binomial. The second term in each of the factors is the square root of the last term of your original binomial. And the sign inside the factors is 1 is positive and 1 is negative. And when you do that, that causes that middle term to add to be 0. Okay? So that's the pattern we see. We notice there's a minus sign between two terms we can take the square root of. Then when we do our factors, the first term is the square root of the first term. The second term of the factors is the square root of the second term, and one of the factors is positive and one is negative. So I've kind of restated that a couple times. Let's move on to some other examples for today. Now we're going to do these mentally, which means we're not going to do the box. We're going to recognize, is this a difference of squares? We have a minus sign. We have two terms on each end of the binomial that we can take the square root of. So we factor it as a difference of squares. The square root of the first term, square root of the second term. One of the factors is plus and one is minus. Okay. D squared minus 21. Do we have a perfect square root? A perfect squares there, yes. Subtraction sign between. So we have D and D. 120 square root of 121 is 11. And we have a D plus 11 and D minus 11. Okay. Perfect square here. Subtraction sign between. Square root of 9h squared is 3h. 3h. Square root of 144 is 12. And we have a minus and a plus. Now if I put the plus for second, the plus factor second, that would not matter. Let's go ahead and just do that. We can take the square root of 25k squared, that's 5k. The square root of 64j squared is 8j. Be sure you put that letter on it. And one of the factors is minus. Notice I put the minus one first this time. It does not matter. It will still multiply if you use FOIL or double distribution to give you, you have to multiply these to give you your original answer, and it's a good idea to check. 16x squared minus 49y squared. Okay, difference of squares. Verify that. We have 4x and 4x. And we have 7y and 7y. And we have one is 4x minus 7y, and the other factor is 4x plus 7y. Again, can take a square root of each end, divide it with a minus sign between them. So we have 2z, and we have 2z. 9a and 9a, and one is a plus 2z plus 9a, and one is 2z minus 9a. Now you notice I wrote it backwards this time. I wrote the plus sign first and the minus sign second. Doesn't matter. Can we take is this a perfect square polynomial? We can take the square root of 4a squared and get 2a and 2a. We can take the square root of 25b squared and get 5b and 5b. But I told you, this is not a minus. It must be a minus. If it's not, there's no real solution. We'll learn in Algebra 2 how to get an answer for that, but it's what we call a complex answer. And so for now, we're going to write prime. There's no real solution for that, so you cannot factor that. All right, in 10, we have a fraction. Well, the square root of 9 is 3, so remember you multiply the denominators. So this is a perfect square polynomial. We have a difference of squares. We have 1/3. 1/3 times 1/3 is 1/9. So we have 1/3 times 1/3 in C. And we have 8d, square root of 64 is 8d squared is 8d. And one of these is minus, and one is plus. And we're done. Now on your homework, you're going to have a lot of these difference of squares. All the front page, I think, is difference of squares. The back page, you have to choose. You might have one of these with a plus sign, so watch out for that. You're going to have trinomials where you need to use the box. Other methods, but we're going to go back and you have review. So get busy on your worksheet, and we'll talk tomorrow with more factoring.